Alright folks, continuing onwards here, we got section 3.3, using congruent triangles, and I have that down below section 3.2 that we see here. Section 3.2, some ways to prove triangles congruent. So we did that last class to be like, hey, this chapter is about using congruent triangles. Well, you just got to get them congruent somehow. And remember, we had shortcuts that we only needed to find a few things that were congruent, like a few of the corresponding parts, to say that the whole triangle was congruent to another triangle where we had those corresponding parts congruent. So anyways, we spent last section just figuring out how we can get triangles to be congruent, or how we would know those two triangles are congruent. Now today, this section that we have right here, section 3.3, is going to be, now that we have the triangles congruent, what can we do with them? What can we do on top of this? Once we've used one of those triangle congruency shortcuts, and now we have the triangles congruent, what can we say next? What's our next move as we continue building onward here and improving our skills so we can tackle some bigger things here? So let's go ahead and read this right now. It says our goal in the preceding section, right? That's section 3.2 right there. That was what preceding means the one right before this. It was to learn when to conclude that two triangles are congruent. Right? We had some shortcuts to get us there. We can do it a lot faster now. Our goal in this section is to deduce information about two segments or two angles once we have shown that they are corresponding parts of congruent triangles. The following example will help illustrate this technique. Okay, so I'm not going to show you that example. We're going to dive into it right now. But the whole idea of this, as you're seeing here in section 3.3, is very simple, right? Once you have proven you have congruent triangles, then what can you say about two segments or two angles? One segment in one triangle and this corresponding segment in another triangle. I have an idea of what you can say afterwards, and I think you have an idea of that. So let's just take those ideas and run with them. Let's get started now. Alright, so quick agenda of today's class. We have some listeners. So section 3.3, I kind of already just gave an introduction of that. I think it's going to be not too hard of a concept, but the problem might be kind of hard because they're kind of proofs, but not too hard of a concept. You just need to practice it and get better at it. And doing section 3.3 is going to help you just be a better proof writer and planning out how you can prove things going forward here. So anyways, the actual content of section 3.3 isn't too much. It's not super crazy. It's, if you understood what I was saying in the introduction, you're going to understand what you need to know about section 3.3. So anyways, I'm going to do today's class. I'm going to talk a little bit about a few things first. Firstly, I don't even have it listed here actually, but what we're going to do is a quick review of section 3.2 because I want to remember you to remember what are some triangle congruency shortcuts and maybe some things that aren't triangle congruency shortcuts. So we're going to kind of do that first. And then after that, I actually have written down here, I wanted to point out about in these triangle proofs, right? Proving one triangle is congruent to another triangle. I wanted to identify this to you that you're often going to have to use the reflexive property, right? When saying one triangle is congruent to another triangle. What do you think I mean by that? The reflexive property. How might reflexive property come up in the proof from one triangle to another triangle? What is the reflexive property again? Well, that's saying that a certain shape or a certain feature, right? A certain part is congruent to itself, right? Is congruent to itself. So the reflexive property of congruence can help you write triangle congruency proofs because if something is congruent to itself, perhaps that thing, that part, specifically a segment, right, might appear in more than one triangle, right? Think about that. So you can picture that. What's a side of a triangle that could be a side of another triangle? What might that look like? Okay, if you're having trouble picturing it, stay tuned. We're going to go over that as part one of today's class. Part two is the stuff that's really the key stuff in section 3 with 3.3, which is using congruent triangles to find other things you can say, other things you can prove after you have proven that the two triangles are congruent to each other, right? What's an additional statement we can say from there? And quite oftentimes that additional statement you're trying to say is going to lead to other things that you can say after that. So it's a pretty important thing. And I think maybe you know what step it is when you do that. But before all this, okay, so I sort of kind of warned you of this, that before we talk about that stuff, the reflexive property, and using that to get triangle congruency, and then also doing the, what do we got here? Section 3.3 is using congruent triangles to find things to prove after proving the triangles are congruent. So before we do that, the thing that I was going to preface this with you here is you're going to have to remind me of those things that you learned in section 3.2. So just remind me real quick. Please tell me, what were the 3 triangle congruency shortcuts that we've introduced so far. Because it's important that you keep track of these. You have these in your notes, and you can break these out at any time on the spot. And usually in class, I'm just staring at you, be like, I'm pointing at you, young lady. I haven't heard you talk in a little while. One of those three, give me one of them. Give me two of them. Okay, what was the first one we did, for instance? Yes. We had this right here, side, side, side. Yes, side, side, side. So if all three sides of a triangle are congruent to three sides in another triangle, then the corresponding sides would all be incongruent to one another. And we would know that the two triangles were congruent through the SSS congruency shortcut. Okay, what if we happen to know an angle, right? What else would we need to know? We would know to know an angle and the two sides that include the angle. So SAS is another triangle congruency shortcut. So it was SSS, and then we did SAS, and then finally what? ASA. Finally, it was ASA for the last third and final triangle congruency shortcut here. Okay, so reminder, the letter that appears in the middle has got to be included about the two letters that are adjacent to that one in the middle here. So a side and a side includes an angle because an angle is made up of two sides here. Okay, so the congruent sides that we're aware of in both triangles, we're also aware of the fact that those angles are given to us, or we've already proven are congruent to us in order to complete the SAS criteria to prove that the two triangles would be congruent to each other. And then we would know that all the other parts are congruent. Okay, but this is just what we need to know at the bare minimum first to know the triangles are congruent. Or we could have known this, right? We could have known this, that the shared side between two angles that we would know are congruent, that side's congruent to its corresponding side in another triangle, the two triangles congruent to each other. So make sure you know this, make sure you love this, and make sure you can use it in the future here. Okay, so just building on this a little bit, again, a little bit more background into section 3.2 before we launch into section 3.3 stuff. Is we had a little conjecture right here. So I know a lot of these kind of shortcuts here, and remember I said we're only going to have 3 of these. In future sections, I forget exactly when in this chapter, but in future sections, you're going to get more than just these 3 triangle congruency shortcuts. There are going to be other acronyms you're going to learn. So I'm just going to toss things out there that may or may not be a potential triangle congruency shortcut. So for instance, right, we've already talked about SSS, we talked about SAS, we talked about ASA. So here we have 1A, we have 2 A's right here. What if we had all 3 A's, right? All 3 angles in one triangle congruent to all 3 angles in another triangle, and therefore we would have correspondences there between the 3 angles. And what about that? Would that guarantee the 2 triangles are congruent? And this is similar to, right, SSS. Well, if it worked for sides, right, 3 sides all being congruent to the other 3 sides of another triangle, the triangles were congruent. So angle is a little bit different than this, though. So let's take a look here. I think you know the answer. I wanted to call this out because this does come up in the future, not in congruency, even something else we'll study here. If we have a triangle like this, and we're looking at the 3 angles here, 3 angles right here, can I draw a shape, another triangle, that has these 3 angles, these 3 measurements right here? And will that triangle, does it have to look exactly like this? So I know that the 3 angles are going to determine the shape, right? The shape that we see here, the specific type of triangle we have here, for instance. That's what angles determine. But do angles determine size? No, angles do not determine size. So here, if we move the angles over and we get the green one there and the red one there and the blue one there, and then whoop, draw a triangle, are these triangles congruent? No, they are not. And therefore, AAA does not guarantee that the triangles are congruent. So AAA is not a triangle congruency shortcut. Okay, so we're still just stuck with SSS, SAS, and ASA for now. Let's look at this one here. That being said, oral practice, ready, set, go. Who am I calling on right here? Is, is triangle ABC, is that congruent to triangle DEF? And if so, give me the reason. Ready, set, a go. Who's going to tell me first? Are these triangles? Do we know for sure these triangles are congruent? They look congruent. Who's going to tell me? Check it out, and by what reason? Did you say SAS? Did you say SAS? Well, I have 2 sides congruent, 2 corresponding sides congruent. This side congruent to that side congruent to that side, and I have an angle, right? I have an angle congruent to another angle. So guys, this is SAS, right? Is it? Is it SAS? No, you guys are getting good at this. I can't trick you guys really anymore here. No, this wouldn't be SAS here. So check it out here, right? This is a side congruent to another side and a corresponding side congruent to its corresponding side over here. So I have SS But do I have the included A, right? Do I have the included A? And I do not have the included A. So I don't know if these two angles are congruent. So I can't use the SAS congruency postulate. And this is an A here, but if you look at this, right, and we have this consecutively, this does not spell SAS. It does not spell SAS, and it does not spell ASA. It spells something else. So to paraphrase a teacher your siblings may have had in the past, Mr. Evans right here, if you use the ASS postulate, then, my friends, you are an ASS. Okay, so ASS is not a triangle congruency shortcut either. And more elegantly, it's referred to as the SSA. Okay, so keep that in mind, the SSA. So the SSA does not guarantee congruency. There's actually two different triangles congruent to triangle ABC through SSA. So this is another thing I wanted to point out here, that this is one triangle. So SSA does not guarantee congruent triangles, but it to point out here that there are actually two triangles that you can oftentimes draw that have an SSA correspondence and aren't congruent to one another. So check this out here, that triangle ABC, right? Triangle ABC, right, could be drawn like this with a side length of this, a side length of this, and an angle like that. And check it out here. Triangle ABD has the same side, right, because this is congruent to itself through reflexive property. And this here, BD, congruent to BC, right? Congruent to BC here. And angle A, it's congruent to itself. So this larger triangle, triangle ABD, has an SSA correspondence with this obtuse triangle that we have right here, triangle ABC, SSA right here. But are those triangles congruent? No, they clearly aren't congruent right here. Triangle ABC is not congruent to triangle ABD. So once again, SSA is not a triangle congruency postulate. Okay, so AAA doesn't work. SSA, does it work? No, it doesn't work. We're stuck with SSS, SAS, and ASA for now. And if I said that enough, I hope I have. Hopefully you got it, and hopefully you can work with it going forward. That being said, we're now on to part one. That was the whole thing we just did right now was just kind of a review of section 3.2. I just figured I had time to go with it, so I'd roll with it. I think it's going to make you better, hopefully, make some of you guys better. But we're now into part one of today's class, which is using the reflexive property in proving congruent triangles. Here, this is something that I need to kind of identify to you directly here, because a lot of people don't see this when they're trying to solve problems like these. So here, problem right here, we got a little diagram action right here. I color coded it to make it a little bit easier to see at least. And I'm asking here, are there any congruent triangles? Ones we would know for sure are congruent. Well, let's look at these little guys here first, because there's actually several triangles in this. How many triangles do you see? I see 5 triangles total. There might be more, right? Sometimes I can't get them all, but I see 5. I see 1, 2, 3, and then I see these large guys here. Yes, these large guys here. This bottom one, let's call this point O right here, AOD. That's clearly not congruent to these two guys right here. So these two guys look like they could be congruent, right? This angle is congruent to that angle because they're vertical angles, right? This side's congruent to that side because it's given. But wait, is that all we know? Looks like that's all we know. Okay. Is there another? I give you the answer right there. Are there other triangles we haven't looked at yet that could be congruent to one another? Well, what about this? What about the one in green that's highlighted here, and then this one in white, but it's all also overlapping the one in green, so it looks green at the bottom here. So triangle ADC and triangle DAB, are they congruent to each other, and how? Okay, by now, normally in class, somebody has told me why they're congruent, and they're congruent by SAS, actually. SAS. Well, question here, this is SAS. It doesn't appear that we've been given all this, so how are we deducing this, that triangle ABD is congruent to triangle DCA by SSS? Because here I see a side congruent to another side, so there's an S, and then I have an A here, right, an angle's a 90-degree angle here is going to be congruent to another 90-degree angle, so that's good. So this angle's got to be included. So how do we get the third side? What is the third side right here? Oh, this must be the third side right here, right down here. And what can we say about segment AD? Segment AD. Oh, look, segment AD is a part of both triangles, right? Part of both triangles. So I got to call this out because a lot of people have trouble seeing this when they start tackling the problems right here, is that oftentimes triangles are going to be overlapping. And if they're overlapping, they share sides. And that's great because sides are usually corresponding parts of two triangles. And they can help establish a congruency because that's two sides, right, that we can say are congruent to one another. So a pair of sides are congruent to one another. We just got to get another angle and then the side that also includes that angle, and then we're good to go through SAS here, okay? So what we can do is, right, because AD is part of both triangles, we can say this down here, that since AD is congruent to AD and AB is congruent to DC because that's a given, and angle A is congruent to angle D because they're both right angles, and right angles measure 90, so they must measure the same as one another, so they're congruent. And then AD is congruent to AD, and what's the reason, actually, for the third part? You got to say all three, right? If you're going to use SAS, you got to say all three. So given, right, given, and then measure 90 degrees because there's a right angle and that equals each other. So that's for that angle. What's the third reason, right? Third reason for the last S here, okay? AD is congruent to AD. Why? Reflexive property, right? Reflexive property. So we have to state that. So I just want to point that out. A lot of these theorems, right? A lot of these theorems you're going to be proving, a lot of these proofs you'll do, you're going to have to use reflexive property as a reason. You haven't used reflexive property in a while, really since it was introduced in chapter 1 to you. So that's the reason why I go over this, is because I want to make sure you haven't forgotten that. And when you approach it and you got a diagram looking like this, you're like, hey, this is super easy. Mr. Fortin showed it to me and I can get it A-okay. All right, so when triangles overlap, we can use parts that they share as congruent parts. Is AD congruent to AD? Sure it is. That's the reflexive property right here. And it could be the reflexive property of equality if you want, right? Distance AD is equal to distance AD, and that's fine here. Or length AD is equal to length AD, and we're good to go. Okay, so it's a quick way of getting two sides congruent to one another. Because they're the same side, they just are parts of different triangles. All right, how about this one here? All right, similarly, so how about this one here? Are there any congruent triangles? Can we prove this? This one's actually, I think, easier than the other ones. How are we going to prove this here? Are there any congruent triangles you see in this diagram? Who sees it? Who sees it? Who's going to tell me? Who's going to earn their points? Their points for the week. Right? I usually have to say like 4 things out loud in class a week. Man, are you glad you don't have to do that? No, come on. It's nice being able to say things in class and hang out, do some geo with me here. Good old Mr. Fortin. Let's see what we got here. Well, we really only have 2 triangles in this diagram. So it's either we're going to talk about this. Actually, we have 4 triangles. Never mind. Take it back. These 2 little guys are triangles down here, but we're talking about the big guys. Big one and another big one right here. Green one, and then this white one that's overlapping the rim. Anyways, are those triangles congruent, and why? Well, we have an angle. We have a side. So is there a way we can prove that this side is congruent to that side? Well, there is, but not yet. Not yet. So if I were doing SAS, I can't do that. SAS, because I don't know if VY is congruent to WZ. So that's going to leave it what, right? We have angles congruent, so we're not going to use SSS. I've just showed you you're not going to use SAS. So what are you going to use here? Well, let's see here. Angle X is part of both triangles, so we can use ASA in this one. Yes, fantastic, fantastic. So let's take a look here, right? Angle X, this is an angle that's part of, look, this triangle right here, right? Part of this triangle right here. It's also part of the green triangle right here, okay? So even though there's just one angle up here, because we have a ray coming this way, and it's going to intersect this side of the angle here, and then we have a ray coming this way, it's going to intersect the other side of the angle here, 2 triangles get formed using that as an angle, right? That we see at least. There are obviously way more triangles we could define where angle X is one of the angles of the triangle, but those are the 2 that we see because of this other given information, right? That WY is congruent to WX, and angle W here is congruent to angle Y. We're going to know these 2 triangles are congruent because we have the reflexive property here, right? That angle X is congruent to angle X. It's congruent to itself. So we got to say reflexive property as the reason there before, right? Before we say ASA, So I'll do this when we go into the main lesson of today, but you got to say, if you're going to use ASA to prove that 2 triangles are congruent, you got to show me one angle, its side that's included between a third angle here. You got to say 3 different things. Check 3 boxes, angle, a side, and an angle, and then you can use ASA, as long as that side's the included side between the 2 angles here. All right, is that all clear, right? So if you're doing this, if you're drawing a diagram, right? If you have the diagram right here, remember I said before you actually write the proof, mark up your diagram so that you know exactly what to write when you start the proof here. Okay, this is all given to you, so maybe you're marking this down if it's not marked down yet, and then you might notice, hey, well, my goal is to get this triangle congruent to that triangle. Well, hey, I can just mark this down. It's congruent to itself, so you don't need to repeat this tick mark thing here, this 2 tick mark thing here, because this could just be a reminder to you that this angle is going to be said to be congruent to in this triangle and then in this triangle. And for that, you just need to write angle x is congruent to angle x by the reflexive property. And there we have it. And finally, we are now on to part 2 of today's class, using congruent triangles to prove other things. And I think we know what step we're going to do. Once we have triangles congruent, what can we say? And to say that, for instance, 2 sides or 2 angles are congruent, I think you know, and we'll get into that in a second. Anyways, doing a little proof action right here to get started with our really looking into section 3.3 stuff. Given, do we do the given yet? No, we don't do the given, but let's just start simple here, okay? So this is just kind of more section 3.2 stuff, is proving if we had a triangle ADB and we had triangle CDB, right? We're trying to get those triangles congruent to one another. So A corresponds to C, D is in the middle here. So this has got to be angle D right here, and this has got to be angle D right here. And angle B, angle B in this triangle is DBC, and then this triangle is DBA, and they correspond. So anyways, we have that there, and we got to prove that the 2 triangles are congruent, okay? Actually, wait, first a second. Can we actually mark up anything right now? Do we know that these are perpendicular? No, we don't know that BD is perpendicular to AC yet, so we can't actually mark that up. What do we know is congruent to itself? That'll actually be helpful for us. Yeah, we know that BD is congruent to BD, so maybe you're marking that up, but I actually saved that for after I marked up my givens, because usually, right, you start a proof and you're given information, and then you can mark it up right away. So here in this problem, you're given this. So actually, wait a second, we are going to be given that BD is perpendicular to AC. Okay, so that's nice because that's going to tell us these 2 angles are congruent because adjacent angles formed by perpendicular lines are congruent to each other. You can say that as the reason. I actually said a different reason to prove that these 2 angles are congruent when I do that in the proof. Okay, we are also given that AD is congruent to CD. So we marked up AD and DC are congruent to one another. And now we have 2 parts. That's good. Are all of our shortcuts? How many parts do we need to get are congruent? From one triangle to another. We need to get a third part here, okay? So we have SA, and we can either get an S here, or we can get another A here, right? So it could be ASA, or it could be SAS. What's it going to be? Well, is there anything else we can mark up? Yes, you bet there is. You bet there is. We can mark up BD congruent to itself, right? Why can we mark it up that's congruent to itself? So we can mark up any shared sides between 2 triangles. BD is a side. Look at this here. We see BD right here, DB, and DB right here. So we're very easily be able to know we can say DB is congruent to DB by the reflexive property. And that's going to take care of this correspondence. DB corresponds to DB. So we have one side correspondence here. We got to say then the angle and then the other side, and then we're good to go to use SAS to get the triangles congruent. So let's do it here. Given, get it out of the way. We got our givens there, okay? Next step, okay? So I don't know why the book did this. I'm kind of copying this from the book. But, right, when you have 2 perpendicular lines, they form adjacent angles, right? Adjacent angles here. Well, we know these 2 adjacent angles. They're congruent to each other, right? Because they got to measure 90 degrees. So in the book, they do this a little bit differently. I think I stole this one from the book, but they said it a little bit differently. So what you could do is, because you have perpendicular lines, you can say, since they're perpendicular lines, then they make right angles, right? Right angles measure how many degrees? Well, 90 degrees. So angle ADB is a right angle, and angle CDB is a right angle because the definition of perpendicular angles, we would know that. And then we would know that both measure 90 because of the definition of a right angle, okay? So we can say that the 2 angles measure the same amount, and therefore they're congruent, right? We don't need to say that part. We can say through definition of perpendicular lines, right? It gets us to right angles, and then definition of right angle gets us to that they have the same measurement, and we're good to go there, okay? So here we got our angle, right? We have our angle. We just need to get the sides that include that angle here. All right, step 3, BD is congruent to BD, and we know that because of what reason? Guys, we just did it in part 1 of today's class. You're all shouting it out. Thank you very much. Well done. That's a reflexive property of congruence. We're good to go. Okay. Step 4, we have triangle ADB is congruent to triangle CDB. We can now assert this for what reason? Okay. We can assert this because, again, SAS postulate. We see it. The nice thing here is you can look up to your diagram and be like, I see it. This is S, this is A, and this is S, right? SAS, SAS. We have an SAS correspondence here in terms of congruency. So we know that the whole triangle is congruent to one another because that is a shortcut that we are assuming we've accepted here. Okay. So in steps 1, 2, and 3, right? Steps 1, 2, and 3. So just to point it out here, in order to use SAS, we need to say 3 things, right? In step 1, we got a side. In step 2, we got that 2 angles. And in step 3, we got another side that includes, right? Includes the angle that the other side includes as well. So we know that we can say SAS here. So notice here, you need to say those 3 things in order to then assert that the 2 triangles are congruent to one another. And with that, our proof is done. Heck yeah, we did it. All right, that was pretty easy proof because we did stuff like that just in section 3 too. Where does it go from here? Where are your proofs going to go from here? And they're going to go to a very simple place, right? Geometry, it's not that hard as long as you just watch these videos, you hang out, you do some problems, you check your answers, because, you know, it should be very logical where we go next. Now that we have congruent triangles, guys, what are some more things that we can say? What are some more things we can say here? What else are more things we can prove, right? When I say what are some more things we can say, what I really mean is what are some more things we can prove here, okay? So I got the 2 triangles congruent. What can I say? What is something else I can prove about this diagram? You need me to toss out an example? Sure you do, because there's nobody in class right now. I'm just kind of making these videos on my own. What if I wanted to say this? What if I wanted to prove that, well, angle A is congruent to angle C? In fact, pretend we did all this stuff here. What would you do to prove that angle A is congruent to angle C? Well, you might think, well, if I just could get this triangle congruent to that triangle, then I would be able to say angle A is congruent to angle C because they're corresponding parts, right, of the 2 triangles I just proved are congruent, okay? So, wait, have we proven congruent triangles already? Yeah, we did in step 4, right? In step 4, we proved triangle ADB was congruent to triangle CDB. Okay, so were we allowed to say angle A is congruent to angle C? Well, let's look down here. Is angle A correspond to angle C? Are they in the same position of the triangle naming here? Yep, they're in the first position right there, so that means angle A corresponds to angle C, and therefore in step 5, you sure as heck better believe we can then say angle A is congruent to angle C. Reason, right? This is the big thing for today's class is reason. Yes, my friends, it's there. I'm putting it on there for you. The reason is corresponding parts of congruent triangles are congruent. And if you haven't forgotten why that's so important, I put it up for you right here. And what you need to do, okay? Stay awake, my friend. Stay awake. You know what CPCTC means, right? It's written out for you right here. Corresponding parts of congruent triangles are congruent. The T is triangles, and this last C is congruent. The first C, though, is corresponding. Be careful of that here, okay? So once you get triangles congruent to one another, one of the most common steps in geometry, what you're going to say next is you're going to say CPCTC, because we want to get specific parts of those congruent triangles congruent to one another. And there we have it, friends. There we have it. Our first geometric awakening happening today. More will come. Trust me on this one. All right, now that the triangle's congruent, well, what are some other things we can prove? Well, maybe you already thought of some already. I'm just going to suggest another one right here. What about this? Can we say AB is congruent to CB? What do you think? What do you think? AB congruent to CB? Well, let's see here. AB, does it correspond to CB? Yes, it does. Yes, it does. We'd have a segment CB and segment AB. They're both in the same position in the naming of this thing here, so they would correspond. Yes, my friends. Why are we allowed to say this? Well, we have congruent triangles. AB and CB, they correspond, and corresponding parts of congruent triangles are congruent. We got it, my friends. We got it. Yes, we do. More CPCTC action. What else? What are some other things? So now that triangles can grow, what else we can prove? What else we have? Right? There are things we can say. All right. Should I be marking more stuff up? We just said this two times ago. We said this right here. Is there anything else that we could potentially say? Well, I have some recommendations down here. We could say the distances are the same. Sure, we can do that, but we've kind of already done that already. I don't need to worry about that. AB is congruent to BC, but then also AB does equal BC, right? So segment AB is congruent to segment BC, and length AB is equal to length BC. Sure, we could say that. So we've already said this too, of course, right? That final angle between the two congruent triangles, we can say are congruent to each other here because they correspond to. Okay, so remember, requires basically three things to say SAS, and then there are other three things, the things you haven't said yet. You can use CPCTC as your reason to state that this angle has got to be congruent to that angle, and that side congruent to that side, and that angle congruent to that angle. Yes, my friends. Very nice. So if you haven't gotten the idea of this already, I'm saying it again, right? So make sure you've gotten the idea of what I've been getting at the past few lessons, and that a very, very, very common way to prove two segments or two angles are congruent to one another is to use this, my old friend, hello darkness, my old friend, CPCTC. And if you use that, you know it, my friends, you will have had the geometric awakening. You'll be good to go. You'll be able to have conversations with people in college, and geometry will come up, guys. Will come up when you have these conversations with people in college from all around the U.S. and all around the globe. People come to college. They talk about geometry, and you'll be talking to somebody and be like, "Hey, man, I had this crazy guy in geometry in my 10th grade. Man, this guy was nuts." And then your friends that you met, they'll be like, "Well, did he talk about CPCTC?" Because they'll be from like Iowa or something like that. And they learn about CPCTC in Iowa also as well. They do. And then that's going to be the first thing they say, because that's the first thing anybody ever says about geometry. And you'll be like, whoa, yes, he did talk about CPCTC. He talked so much about it. He talked way too much about it. What the heck, man? What is with these 5 letters? But hey, it's a very easy way to prove two segments or two angles are congruent. So hey, of course he did. It's all good. CPCTC, let's talk to more. Let's make more friends at college over this fact that corresponding parts of congruent triangles are congruent. You will. It's a good way to make friends in college. Trust me. Step 1. Okay, so in order to do this, just to think about what we just did right now, you're trying to get two angles to be congruent. Can you use CPCTC? Well, you'd have to do the stuff first. Step 1, you'd have to identify two triangles in which the two segments or the angles you're trying to get congruent are corresponding parts. Sure, right? In the last diagram, if we wanted to say, yeah, angle A is congruent to angle C, well, hey, first step, working backwards, let's just get these triangles congruent. And then A is definitely a corresponding part to C. They look pretty darn congruent. Okay, so that's step 1. Step 2, you got to prove that those triangles are congruent. Okay, so we prove triangles are congruent first. The last example, we did that through SAS. Third step we'd have to use the CPCTC action there. So then we would state the two parts we're trying to get are congruent, right? In the last example, we're trying to get angle A congruent to angle C. So we can say that now finally, because angle A and angle C are corresponding parts of congruent triangles and are therefore congruent by definition of triangles. And so we just say CPCTC in a proof in order to say it as quickly and efficiently as possible and save our wrists for writing for more important work that we have after this, okay? So an example here, right, you oftentimes, and I think I want to call out when you're doing this process right here, oftentimes your triangles that you get are congruent will share sides, right? Share sides. So this is taken directly from the book. You might have something like this as a homework problem here, but if I'm looking to prove that angle LMK is congruent to angle KNL, what might be two triangles? Let's use this process. And my two triangles in which the two segments or angles are corresponding parts. Well, here's the angle here corresponds to here's the angle here. What are the two triangles that correspond? That might be congruent. Yes, this one on the left here and the one on the right here, right? This would be an angle and this would be an angle, right? They look like pretty congruent to me. This side looks like it could be congruent to me there. This side looks like it can be congruent to me there. Let's see what's given to us here and see if we're able to prove this and just talk through it right now together here. All right, LM. So in this problem, this is taken directly from the book. LM is congruent to LN. Oh, that's nice. And MK is congruent to NK. Okay, that's nice. I'm going to start marking this one up so we see this one here. LN congruent to LM and MK congruent to NK. How would you prove this? How would you ultimately prove this? So what's going to take to get there? Okay, do we have the two triangles? Can we get these two congruent to each other? Why? Why? How? Well, KL, this third side, this triangle, and I'm talking about the little guys. I'm talking about that side, this side, and this side. Is that triangle congruent to this side, and this side, and this side? And the answer is going to be yes, totally, because this third side, it's congruent to itself because it's the third side of both triangles here. So you have to use reflexive property here, and then your two givens, and then you use what shortcut? Triangle congruency shortcut. That's right, SSS. And finally, we'd be able to use CPCTC to get what it is we're trying to prove, which is that angle LMK is congruent to angle KNL, and we're good to go there. So that's the whole process. I did that very quickly. Let's just do a proof together. Let's do a second example right here, a proof together, or we're going to do that process here, that three-step process, okay? In this one here, we're looking to prove AB is it congruent to CE. So maybe I mark that up and put a question mark. You could do that because, well, have we step one? If we mark this up, we're trying to get these two things congruent. Can we identify two triangles that might be congruent? Well, there are only two triangles in the diagram. Can we get, so our goal here is, can we get this triangle congruent to that triangle? And then once we get them congruent, we're going to use CPCTC to say that AB and CE, they correspond, so therefore they must be congruent. Anywho, what's given to us here, D is the midpoint of B and AC. Okay, so D is a midpoint of two segments, midpoint of that segment B, and midpoint of this segment AC. Okay, yes, very nice. So step one is, can we mark anything up? Can we mark anything up? Well, does the given actually allow us to mark anything up? Well, yes and no. We know that since D is the midpoint of B and AC, that it's going to divide both segments into two congruent segments. So we could potentially mark that up. We just can't forget to state that we put our given down and then state why we know that BD must equal DE in terms of length BD equals length DE. And I think you know the reason for that there. So let's just get started with the proof here. Oh yes, so we can mark this all up here. So we have a side here, a side here. We're not going to use SSS here. Why do I know already that we're not going to use SSS? Well, we're trying to prove that this side is congruent to that side. So we're not going to use the SSS postulate because we don't know yet whether AB actually equals CE. So we have two sides, two corresponding sides are congruent, two pairs of corresponding sides are congruent. So that leaves what? Triangle congruency postulate. That's right, SAS. SAS is the only other one that has more than one side correspondence congruence that is in a shortcut. So we use SAS, and can we get that angle, right? Even when it's not given to us, do we know that angle ADB has got to be congruent to angle CDE? Yeah, we sure as heck can mark that up because these are what angles? That's right, vertical angles. And vertical angles are congruent. So let's get this all down in our paper here. If we're doing this problem on a test, hey, you can get this thing done in maybe like a minute and a half, right? Tops, I think, for this one. Okay, step one, you're robotically done. Pretend you're doing this on the test. You're writing this down. Step one, D is the midpoint of segment BE and AC. Reason, of course, given. Okay, you're going to use that given. What do you need to say next, right? We have that down, written it down as a given. What does that allow us to connect to? What does this connect to help us get closer to this SAS? Right, a midpoint creates congruent segments, right? Congruent segments. That means that BD has got to be equal to DE, and DC has got to be equal to AD, or segment AD is congruent to segment DC. And that is just the definition of a midpoint. Remember, definition of a midpoint, that means part equals part, not part equals 2 times or half the whole, right? So it's not a part and a whole relationship, it's part to part relationship. And that's what we want right now, right? We want that side and that side of these two triangles to be congruent to one another, so we have a set of corresponding sides congruent. Then we could say this. What's the reason for this again? That's right. Vertical angles congruent. Let's put it down. Vertical angles congruent. Next step. Okay, cool. So now we have our criteria here. We said 3 sets of things are congruent. 3 pairs of things. 3 corresponding pairs are congruent. So what's the thing we've decided we're going to use here? That's right. SAS. SAS. We're using the SAS postulate to say that triangle ADB is congruent to triangle CDE, and we're good to go here. Okay? Was that what we were trying to prove? Were we just trying to prove triangles are congruent? No, we wanted to use the fact that these triangles are congruent to then state that segments must be congruent here. And yes, these segments are corresponding parts of congruent triangles. And I see here AB corresponds to CE. There we go, CE. So we know those 2 segments would have to be congruent to one another. And reason, CPCTC. Corresponding parts of congruent triangles are congruent. So remember, the first word is corresponding here. And you know that because you have stayed what? You stayed awakened. You stayed awakened. You are awake. You're geometrically awake right now, my friends. Yes, you are. And let's do it here. All right, so just going to put this up here because we have a diagram here. It always takes time to get used to a diagram, so we're looking at it. I can ask you follow-up questions. So rather than get used to a new diagram, just hang out with this one a little while longer. It's a lot easier to do it that way. So now that we've proven this, what are some other things we can prove about the parts of these triangles? I can think of 3 more things. So take 15, 20 seconds. Talk with your group, actually. I think you can come up with these 3 things. I think you can. I think I can call on you in the dark and you're going to have a perfect... B and E correspond right here. And I can also say that angle C is congruent to angle A. Okay, angle A. So that's 2 things, right? That's 2 things I added. This one right here I added. This one right here I added. So I'll circle them both. So I've only said really 2 things that I can prove about the parts of these triangles right here. What's the 3rd thing though? What's something special I can say about a pair of corresponding parts here too that hasn't been said yet? Because everything's marked up as congruent. What's the other thing I can say? Well, let's see. Let's get our answer down here. I can say those 3 things. Okay, so I marked up the first 2. What's the 3rd thing? Ooh, nice. I can say that AB is parallel to EC. Parallel to EC. And why can I say that? Why can I say that? Well, these guys here are a special type of angle relationship. And these guys here are also a special type of angle relationships. They're what? Alternate interior angles. Look at this here. We have 2 lines, right? And this is why it's hard to see this because these are line segments, not lines, right? But they're line segments that would be contained by a line. And here, BE would be a transversal of this line CE and this line AB. So it might be easier if I draw it in a little bit further, right? When you have a pair of lines cut by a transversal, and you know that alternate interior angles are congruent to one another, then you would know what about the 2 lines? That's right, they are parallel. They would have to be parallel to each other. And so that's the 3rd thing. Hopefully you got that on your own, but if not, I have it written down there, and then I'll definitely come up in problem sets. Okay, example 3, 3rd and final example here is you're actually given parallel lines. Nice, that should give you a hint of what to do in this problem. You're given parallel lines. You're also given that AB is congruent to CE. Very, very, very nice. And so our goal here is we want to prove that D is the midpoint of AC and BE. So this is feels kind of like the converse, but not really, because you didn't have to prove this action right here. You should have proved that action here on the last one. Anywho, let's go ahead and get into it. Ready, set, go. Go ahead and mark it up right now. Okay, so we're given AB is congruent to CE, and then marking it up just makes it easier. That's what I'm going to show you here. So we have a side, we have this here, and sure, we have the vertical angle right here. I don't know if I marked that in, the vertical angle. So I can mark that vertical angle. I'm not going to do it because it's not actually helpful. This vertical angle isn't helpful because we have this side right here, and this angle here, you're not going to be able to use ASA with this side here because ASA, because this angle here isn't going to include this side, right? This angle here has this as a side and that as a side. This wouldn't be an included side here. So what I need to do is I need to get that angle congruent to that angle, and that angle congruent to that angle. What's going to allow me to do that, right? To say this, because ASA is really my only choice here because I'm only given one side. It's congruent. So one pair of sides are congruent. For now, it's going to be ASA, okay? Why would I know angle C congruent to angle A, and why would I know angle E is congruent to angle B? Well, I'm given that information right here, okay? So let's get into it. Let's go ahead and write it on out. Given, you're given that, right? You're given that, okay? So given this, that AB is parallel to EC, then I would know that angle A would have to be congruent to angle C, and angle B would have to be congruent by angle E because those two parallel lines are cut by a transversal here and transversal here. And we would know what about these alternate interior angles? They'd have to be congruent, okay? So step 2 is what we have written out right there, okay? Now we have two pairs of angles. That's nice. The two pairs of angles we got, and what's given to us also is that the included side's congruent. Awesome. So I'll put that down as a given as well. It's okay if you did that on part 1, right? Lumped all the givens together, put them all in. But sometimes teachers, especially in books, will just kind of build on it independently. I wanted you to think about this part first, why those two pairs of angles were congruent, and that had to do with the parallel lines. And now I'm bringing that final given right there, just so I got my ASA mentioned in the proof. So now I can do it. I can write that triangle ABD, right? So AB equals EC. So ABD is congruent to CED, right? That would be the correct correspondence, and it's an ASA congruence right here based on our information we have in steps 2 and 3. Finally, D is the midpoint of AC and BE. Can I actually say that yet? Can I actually just finish this proof? No, it's going to be 2 more steps here, but I am still going to use CPCTC next. So I'm going to get that D is the midpoint of AC and BE because what can I say now? Well, I can say that BD is congruent to ED, for instance, because they correspond to one another. Nice. If I knew that this were congruent to that, then D would fit the definition of a midpoint here, okay? So what I'm saying here is that BD congruent to DE, I got that right here, and AD would have to be congruent to DC because these are corresponding sides of congruent triangles, and that's CPCTC right here, okay? I have that written down. Finally, I can wrap up this proof. D is the midpoint of AC and BE. And in step 5, we stated the information that was required to establish that D is a midpoint. And we're good to go. Definition of a midpoint. And here is our summary slide. Yes, guys, you've already seen this, but this is the big idea of today's lesson. And again, sometimes when I spend a long time on videos like this, I might be like, well, why did I spend all the time watching this? Well, you have trouble. People have trouble figuring this out on their own. That's why I spend the time doing this with you and seeing it all out. So we have our summary slide, and really this is just what you need to keep in mind. So this little voice in your head, this little Mr. Fortin voice in your head is telling you to do this. If you're trying to get a specific side, for instance, like we're trying to get our specific angle congruent. I'm trying to get this congruent to this. Well, what I'm doing is identifying 2 triangles that are congruent to one another or potentially congruent, and then I'm proving those 2, right? And looking at my givens, I'm trying to get those 2 congruent. Once I do, CPCTC will confirm that that angle is congruent to that angle. That's corresponding parts of congruent triangles. They are congruent. And with that, this is what I'm thinking as of now for homework. I think you're going to do great. And I think we have a second day of this tomorrow, but it'll be mostly practice. Take care, guys. This was a lot of fun again, and I look forward to doing more work with you soon. Bye.
day.